3a. The demand function for a certain product is given by, so we have P is equals to 0.3 Q minus 5, where P is the selling price in shillings for product per unit, and Q is the quantity of the product demanded in units. The total cost of the firm is given by, so given that function, required, number one, the break-even point quantity in units, break-even point. Now we know very well that at break-even point, profit is equals to 0. And how do we get the profit? Profit is total revenue minus total cost. And total revenue is the price times the quantity. So therefore, let's get the total revenue. You take the price, so you have the price function, 0.3Q minus 5. Now that's P. Then you multiply by Q to get the total revenue. So total revenue will be 0.3Q squared minus 5Q. Now we get the profit. So to get the profit, you take the total revenue minus total cost. So you have the total revenue, 0.3Q squared minus 5Q. Then you minus the total cost. We have the total cost function, 1.7Q squared minus 18Q plus 15. And you're saying that at break-even, profit is equals to 0. So therefore, the profit is 0.3Q squared minus 5Q. Now we open the bracket. When you open the bracket, the sign will change. So it will be minus 1.7Q squared plus, this was 18Q minus 15, and is equals to 0. So bring the right term together. So profit is equals to, you have 0.3Q squared minus 1.7Q squared, and you'll get, what do you get? So you'll get negative 1.4Q squared minus 5Q plus 18Q. You'll get 13Q minus 15 is equals to 0. So, but what we need here, we want the break-even point in quantity. So quantity is all about the number of units. So you have the profit function. So if you have the profit function, now let's get Q. Now, if you look at this profit function, because at break-even profit is equals to 0, now this is what we call the quadratic function, where this is A, this is B, this is C. For quadratic equation, how do you get Q? Q is minus B plus or minus square root of B squared minus 4 AC over 2. So it will be minus B, our B is 13, so it will be negative 13, plus or minus the square root of B squared, it's 13 squared, minus 4 AC. Our A is negative 1.4, our C is negative 15. All of it you divide by 2A. So our A is negative 1.4. So give me Q. One point. So number 2, Let's go to number 2 of the question. Now, the level of output that would maximize profit, level of output that will maximize profit. So to get the maximum profit, now that's where the differentiation comes in. So to maximize the profit, you already have the profit function, and the profit function is here, where it's negative 1.4q squared plus 13q minus 15 is equals to 0. So to get q at profit maximization, you differentiate profit with respect to q. So this one will be 1.4 times 2, will get negative 2.8q plus, this is the same as 13q raised by 1. So it's 1 times 13, you get 13. Then you minus 1, q disappears, and is equals to 0. So therefore, minus 2.8q is equals to, so you take this 13 to the other side, is equals to negative 13. Now give me q. Sorry? 4.6. Yeah, so the level of output that would maximize profit. So you're done with that. Let's do another illustration. May 2021, question 1. Pump World Limited assembles and sells computers. The company estimates that if it optimally assembles computers, it could sell between 1,100 and 2,000 computers per month, and the monthly revenue in thousands of shillings over the range of sales could be represented by, so you are given the total revenue function, where R is equals to 1,000x minus 200x squared, where R is the monthly revenue, X is the unit of computers sold per month. X is the number of computers assembled. The fixed cost of the company amounts to 100,000 shillings per month. It's required, it's assumed that all the computers assembled in a given month are sold within the same month. Required, the total cost function. So how do we get the total cost function? Now, in this case, we are given the marginal cost. If you're given the marginal cost, that means they had already differentiated the total cost. So therefore, to get the total cost, you need to integrate marginal cost with respect to x, of which you have been told that the marginal cost function is 200x squared minus 200x plus 400. So we integrate the marginal cost with respect to x. So therefore, the total cost will be, now this x squared. So you add 1, you get 3. 2 plus 1 is 3. Then you divide by 3. 200 divided by 3, you get? So 66.67x cubed minus 200x. This is same as x raised by 1. So just add 1. 1 plus 1, you get 2. You divide by 2. So this is 100x squared plus, this is same as x raised by 0. So you add 1, you divide by 1. So it's 400x. Then you see that when you're integrating, you add c. And c represents the constant, of which for cost, that constant is what we call the fixed cost. And we are told that the fixed cost of the company amounts to 100,000 per month. So you add 100. But remember our shillings, you have been told that they were in 1,000. So that's why you add 100, not 100,000 shillings. We are done with number 1. Number 2. The profit function. So how do we get the profit? Now, profit is total revenue minus total cost. So therefore, to get the profit, we have the total revenue function, where revenue is 1,000x minus 200x squared. Now that's the total revenue. Then you minus the total cost. Now let's deduct the total cost directly. So when you open the bracket directly, the sign will change. So it's minus 66.67 x cubed plus 100 x squared minus 400x minus 100. And this one should give you 0. So you bring the right term together. So profit will be, let's start with this, so it will be negative 66.67 x cubed. Then we have negative 200 x squared plus 100 x squared. Yes, 100 x squared. 1000 x minus 400 should get 600 x. Then minus 100. That one is equals to 0. And number 3, the optimal monthly profit. Now, the optimal monthly profit is the same as the maximum profit. So therefore, number 3, to get the optimal or the maximum quantity or output, you have to differentiate. We have the profit function. So you'll differentiate the profit with respect to f. So negative 6.67 times 3, get negative 200x, then you minus 1 square, minus 100 times 2, get 200x. 2 minus 1, you just get 1x, plus, this is the same as x is power 1. 1 times 600 is 600. 1 minus 1, x disappears. Now we have the profit after differentiating. But what we need is the output. Now this one we have formed is what we call the quadratic function. This is A, this is B, this is C. So how do we get x? Minus B plus or minus B squared minus 4AC over 2A. So minus B, our B is 200 negative. So negative minus 200, you get positive 200 plus or minus B squared. If you square negative, becomes a positive. So it's 200 squared 4AC. So our A, we have is negative 200. Then C, we have is 600. All of it you divide by 2A. Our A is negative 200. So give me x. Ready? 12 point? 1299.5, eh? 200 plus or minus. I doubt that answer. Negative 2.3, so you discard that because we cannot produce a negative unit. Sorry? 1.3, which is equivalent to 1,300 units. Remember our figures were in thousand. Then lastly, number 4. Number 3 was the optimal monthly output. So for us to maximize the profit, we must produce 1,300 computers. Then number 4, the maximum profit of the company. So to get the maximum profit, now we already have the quantity to maximize the profit, which is 1,300 or 1.3. And in number 2, we had the profit function. This is the profit function. So we substitute the profit function, which is negative 66.67 x cubed. Our x, we have it's 1.3 cubed minus 100x squared. Our x is 1.3 squared. Then you add 600x. Our x is 1.3. And then we minus 100. So give me the maximum profit. You can copy. December 2021. December 2021. Question 3B. I'll start question 3A. Question 3A, you explain the following terms as used in Markov analysis. Number one is the Markov process. So that Markov process is the process of the study of movement from one state to another. Then number two, we have equilibrium state. And you see that these are states whereby the current and the future state are the same. Then we have absorbing state. See that absorbing state is a state whereby members can join but cannot exit. Then we have closed state. Closed state is a state whereby no new member can join and no member can exit. Number B. The marketing department of Jacuzzi Limited estimate the daily demand function of one of its product is linear in nature. The demand function is linear in nature. What do we mean by linear function? Now, for linear function, y is equals to a plus bx, but not just a plus b. It is a plus or minus. Plus means that there is a direct correlation. Minus means there is an indirect relationship. That's what we mean by linear function. Then we are told that if the price was fixed at 570, the daily demand will be 400. Yeah, so that means in this case, what we have here is P. Instead of Y, here we are forecasting the price. So price is equals to A plus or minus BX. Now you are told that when price is fixed at 570, when P is 570, the daily demand will be 400 units. X will be 400. So it's A, either plus or minus BX. Now our X is 400 units. So it will be 400B because X is the number of units. So therefore B will be, X will be 400. And then you are told that if the price was increased to 820, now if price now is 820, what will happen? The daily sales would drop to 200 units. A plus or minus, the units now will be 200B. Now, here we need to change this. Now we want to come up with the one decision. When the price is 570, demand is 400. When the price increases, what has happened to demand? Demand has decreased. So that means there is what we call an indirect relationship. When the price increases, demand reduces. So that means it's an inverse relationship. Being an inverse, so therefore it will be A minus instead of A plus. Plus is when they're working towards the same direction. That means they are directly correlated. Price increases, demand increases. But in this case, when the price increases, demand reduces. We read the question again. The marketing department of Jacuzzi Limited estimates that the daily demand function of one of its products is linear in nature. If the price is fixed at 570, the daily demand will be 400. If the price is increased to 820, the daily sales will drop to 200. So that means there is an indirect relationship. The production department has indicated that the marginal cost of producing Q units of the product is given by the following equation. So you have the marginal cost function, where M is the marginal cost, and Q is the quantity, is the number of units produced. The daily fixed cost, it's 1100. So that's our C, or the fixed cost required. the revenue function of Jacuzzi Limited. So how do we get the revenue? So to get the revenue, so first of all, you have to get the price. And to get the price, we need A, we need B, and we have the two equations. So you solve simultaneously. So this one you can multiply by 1, you multiply by 2. So this one made to be 570 is equals to A minus 400B. Here you multiply by 2. This one will be 1640 is equals to A. Actually, this one you don't have to. This one you already have AA. We have AA, you just minus the 2. 570 minus 820. You have 250, which is negative is equals to, and negative 400 minus 200. You got negative 200B. So give me B. It's 1.25. Now let's get A. Now if B is 1.25, so how much will be A? So substitute either the first equation or the second equation and give me A. You get? So you take 200 multiplied by 1.25. 200 times 1.25, 25, that's 50. You get 250. So 250 is 20 plus 250. 0.7 that you get 1070. So you get 1070. So A is 1070. So that means P is equals to A, which is 1070. Now this one instead of plus now will be minus BX. Minus BX. So it will be minus 1.25X. So that's P. Now the question was, you determine the revenue function. Now to get the total revenue is the price times quantity. So therefore the total revenue will be price, which is 1070 minus 1.25X. Our X in this case, sorry. Our price function we have is 1070 minus 1.25X. Now that's P, then you multiply by X. Therefore the total revenue will be 1070X minus 1.25X squared. Number 2. The total cost function. So to get the total cost, in this case, we have been given the marginal cost. So if you're given the marginal cost and you want to get the total cost, you integrate marginal cost with respect to X. We have the marginal function, it's 2Q minus 570. So therefore, to get the total cost, this is a Q raised by 1, you add 1. 1 plus 1 is 2, so divide by 2. 2 divided by 2, you get Q squared minus, this is the same as Q raised by 0, so you add 1. 0 plus 1 is 1, so divide by 1. So it will be 570Q. Then you add C. C is the constant of the fixed cost. The daily fixed cost we have is 1100. Number 3 of the question. The maximum profit of Jacuzzi Limited could meet the maximum profit. So to get profit, you will take the total revenue minus total cost. So therefore, to get the profit, you already have the total revenue function. This is our total revenue, which is 1070X minus 1.25X squared. Then you minus the total cost. So you have the total cost function. So you open the bracket directly, the sign will change. So minus Q squared plus 570Q minus 1100. And at profit maximization should always equal to 0. So bring the right term together. 1070X plus 570 gets 1640X. Then minus 1.25X squared minus Q squared, you get minus 2.25X squared, and then minus 1100 is equals to 0. Now this is the profit function, but this is not what we need. So what we need was the maximum profit. So to get maximum profit, you have to differentiate. So you differentiate profit with respect to x. So this is 1640 minus 2.25. That one you get 4.5. X is equals to 0. So, yes? Which one? Oh, yeah, actually, you see in this case, so x can be q, can be, x is the same as the quantity. So what I have done, I've just converted this, or alternatively, now instead of this one using q, instead of using x, you make it what? Q. So it's the same. So this q and x is the same. So just combine the two. So let me just make this one x squared, and this one instead of q, you make it x. Good. Q and x is the same. So take this to the other side. Give me x. $364. Yeah, 364.4. So that's x. But what we need is the maximum profit. So to get the maximum profit, you have the profit function. Now this is a profit function. So just substitute. It will be 1640x. Our x is 364.4. And then you minus 2.25x squared. Our x we have is 364.4 squared. And then you minus 1100. That's how you get your maximum profit. So you do another illustration. April 2022. April 2022. Question 4C. So the average revenue function of a certain company is given by the function, so AR. Now that's the average. So if you have the average revenue and you want to get the total revenue, so to get the total revenue, in this case, you will take the average revenue, you multiply by the quantity. So in this case, they have used Q instead of X. So you take the average revenue, you multiply it by Q, since you are given the average revenue. So therefore, to get the total revenue, you take the average revenue function, which is 2000 minus 24Q. Now this is the average revenue. Now if you want to get the total, you multiply by the number of units produced. So therefore, the total revenue is 2000Q minus 24Q squared. The cost function is given by the function, so you're given that. In both cases, Q represents the quantity in units required, the profit function of the company. So profit function, profit is equals to total revenue minus total cost. Therefore, to get the profit, you take the total revenue, which is 2000Q minus 24Q squared. You minus the total cost. You are given the cost function. So you open the bracket directly, the sign will change. So it's 6Q squared minus 1440Q minus 1280 is equals to 0. So you bring the right term together. 200Q and then minus 1440. So that one you get 560Q minus 24Q squared minus 6Q squared get minus 30q squared minus 1280 is equals to 0. Number 2 of the question. So I think we have answered number 1. Number 1 was about the profit function. Number 2 is the maximum profit. So to get the maximum profit, so this you have to differentiate. So you will differentiate profit with respect to Q. So this will be 560 minus 60Q is equals to 0. Take 60 to the other side. 560 is equals to 60Q. 56 divided by 6. 9.3. So now this is the quantity to maximize the profit. But what we need is the maximum profit. So to get the maximum profit, you substitute the profit function. Now the profit function is 560Q. Our Q is 9.3. You minus 30Q squared. So our Q is 9.3 squared. And then you minus 1280. That's how we get the maximum profit. So you can copy. Still on the same sitting, April 2022, we do now question number 1. On 1A. Hexadol Limited has been in operation for the last 5 years. The company annual revenue function and annual cost function takes a form of quadratic function. So both the total revenue and total cost, so total revenue and total cost both take the quadratic form. That is ax squared plus bx plus c. That's what we call the quadratic function. The following data was obtained from the record of the company for the last 3 years. So we have the units produced and sold. Now that's X. Can you write it as X? Then we have revenue, write it as TR. Then we have cost, write it as TC. Required. The revenue function of the company, revenue function. Together, revenue function, you see that total revenue and total cost, both of them will take the quadratic function. That is ax squared plus bx plus c. Now let's start with the total revenue. Now for the revenue, we have for 2019, 2020, 2021. So we have 2019, 2020, 2021. The total revenue here we have is 2320. Here we have is 4480. Here we have is 6480. Now that's the total revenue. Is equals to ax squared. Ax squared. Now let's start with 2019. Now 2019, x, the units produced was 4. So it's a 4 squared. 4 squared, you get 16a plus bx. Our x is 4, so it will be 4b plus c. Call it equation number 1. 2020, you do the same. Now 2020 x is 8. So therefore 4480 is equal to, that's the total revenue, ax squared. X is 8, so 8 squared you get 64a. Bx, x is 8, so it's 8b plus c. Call it equation number 2. Then 2021, x is 12. So therefore it will be 12 squared. So it will be 144a. Bx, x is 12b plus c. You call it equation number 3. So we need to get a, b, and c. So how do we get a, b, and c? So now using equation 1 and 2 to eliminate c. You can take equation 1 and equation 2 to eliminate c. So you can take equation 2 minus equation 1. 4480 minus 2320. So 2160, 64 minus 16. 48a plus 8 minus 4. 4b, c minus c. So you call it equation number 4. And then using equation 2 and equation 3 still to eliminate c. Mm-hmm. 2 and 3. So you can take 3 minus 2. So 6480 minus 4480. Get 2000 is equals to 144 minus 64, you get 8a plus 12 minus 8. Call it equation number 5. So now you only have two unknown, A and B. So now using equation 4 and equation 5, now we solve simultaneously. Equation 4 is 2116 is equals to 48A plus 4B. And equation 5 is 2000 is equals to 8A plus 4B. So you have 4, so we eliminate B. So it will be 4 minus 4, you get 0. 48 minus 80, negative that too. 2160 minus 2000, you get? Give me a negative? Negative 5. So we need to get B, we need to get C. Now, using equation 4 or equation 5, where A is negative 5. So let's substitute equation number 5. This one is the easy one. A is negative 5. So 8 times negative 5, get 400. Negative 400, you take it to the other side. 2 minus 2 plus, right? Is it minus or plus? This is minus. 80 times negative 5 is minus. So if you take it to the other side, it will be positive, right? So 200 plus, 2000 plus 400. 24 divided by 4. That's 6. 600, eh? 600. So B is 600. Give me C. Use equation 1 to give me C, of which you'll get 0. We have A. A is negative 5. Can you take 16 times negative 5? Then you add 4B. So it's 4 times 600 equals. What do you get? Then you take 23, 20 minus answer. You get 0. Yeah, we see that for the revenue, there is no constant element. Therefore, it should always be 0. So therefore, you have the total revenue function. Total revenue function is AX squared. Our A is negative 5. So it will be X squared plus BX plus BX. Our B is 600X. Then plus C. C is 0. So that's how we get the total revenue function. Number 2, the cost function for the company. To get the cost function, you do the same. You do that. Both the total revenue and total cost, they follow quadratic function. Therefore, the total cost is equals to AX squared plus BX plus C. And we have the total costs. 2019 was 10,404. Then 2020 was 98.2. And then 2021 was 92.72. AX squared. So there, nothing will change. Now for 2019, X was 4. So it's 4 squared, you'll get 16A BX. X is 4. So 4B plus C. Correct equation number 1. Now 2020, X was 8. So it's X squared. 8 squared, you get 64A 8B plus C. You call it equation number 2. And then 2021, X was 12. So X squared is 144A plus 12B plus C. You call it equation number 3. Then from there, you follow what I have done here. You get A, you get B. Now for total cost, there must be C, constant. Yeah, that one represents the fixed cost. And that one will have answered the question. Good. Then part B of the question of the same thing. Explain the following terms as used in probability. We did probability. Joint probability. See, joint probability is the product of more than one probabilities. Then number 2, mutually exclusive events. And these are events which are substitute or events with some the same purpose. Therefore, if you had to take one event, automatically reject the other event. Then we have conditional probability. And these are probability which depends on other probabilities. Or it was, in case actually it was supposed to be conditional events. These are events which depends on or which are conditional upon the happening of another project. And then we have dependent events. And these are events which depends on the happening of other events. So therefore, if you take event A, you also have to take event B. Good. So we can copy that. decision making. It's on 5C. The management of wall paint manufacturing company is faced with the problem of choosing one of the three products to add to its existing production line. To choose one of the three products. So that means if you want to choose one of the three products, those are what you call the mutually exclusive product. The potential demand for each product, may turn out to be good, moderate, or poor. Now that's what we call the outcomes. We have three options. Either one of the three products, and then the outcome is based on the state of the demand. It can either be good, moderate, or poor, with probability estimate of 75%, 15%, and 10%, respectively. The estimated profit or loss under the three states of demand will, respect to each product, is outlined below. So already given the payoff. That's what we call the payoff table. And you see that payoff means the profit. And I gave you the format of the payoff table. Now for payoff table here, you have the options. And option is what within the control of the decision maker. Then we have the outcome. Now our option, you need to choose one of the three products. You have product silk, matte, or gross. Then here you have the probability for the outcomes. Now this was the format of the payoff. Then the outcome is something which is not within the control. So that's the demand, of which can either be good, moderate, or poor. And we have the probability. Probability that the demand will be good, it's 0.75. Probability that will be moderate, it's 0.15, and probability will be poor, it's 0.1. And then we have the profit. You know that the estimated profit or loss. Now those are the payoffs. Payoff means the profit. So here you have it 70,000. When it's moderate, it's 55. Here we have a loss of 10. For matte, when the demand is good, the profit will be 100,000. When it's moderate, the profit will be 40,000. And then when it's poor, it will be negative 6,000. Then for gross, so 120,000. For moderate, will be 50,000. And then here you make a loss of 40. Required. Advise the management on the choice of product based on the expected monetary value, EMV. So number one is EMV is a summation of the profit times the probability of occurrence. So we have silk, we have matte, we have gross. So for silk, you can get a profit of 70,000 and the probability of occurrence is 0.75. And a moderate, you get a profit of 55,000 and the probability of that happening is 0.15. Or you can suffer a loss of 10,000, probability of 0.1. Matte, it's 100,000, probability of 0.75. 40,000 with probability of 0.15, or you suffer a loss of 6,000 with probability of 0.1. Gross, 120, probability is 0.75, can be 50 with probability of 0.15, or you suffer a loss of 40 with probability of 0.1. Get 59, 750. Now, based on the expected monetary value, that's the average profitability. So you opt the one with the highest EMV or the highest profit, which is 93,500. So therefore, they should introduce product gross. Number 2, compute the expected opportunity loss for each decision. Expected opportunity loss, EOL. Now, for you to get the expected opportunity loss, you have to come up with what you call the loss table. Now, payoff means the profit. So this is the profit table. So we need to come up with the loss table. And how do we get the loss table? You need to compute what you call the opportunity loss. Opportunity loss is the benefit foregone for not making or for not choosing a given product. So here we have the option. We have the outcome. So silk, mat, gross, and then we have the probability. So outcome is good, can be moderate, or can be poor. Then we can compute our EOL. So probability is 0.75, 0.15, 0.1. Now this is enough here. How do you develop the loss table? So to develop the loss table, you use the payoff table and then you evaluate each outcome, not the option. Now these are the options. Now you look at the outcome. So for the outcome, this is what you do. If you start with good, you take the maximum profit. The maximum profit you have is 120. So you deduct all the other profit. For example, you take 120 minus 70, you get 120 minus 100, you get 120 minus 120, you get 0. Then for the moderate, you do the same. You take the maximum profit. The maximum profit you have is 55. Then you deduct the rest. So 55 minus 55, you get 0. 55 minus 40, you get 15. 55 minus 50, you get 5. Or you do the same. The maximum profit you have is? Yeah? -6, correct. Then you deduct the rest. So -6 and minus -10, you get? The difference is 4,000. -6 is 0. The difference between -6 and -40 you have is 20. I mean, is 30? 34. Now, what does it mean? Now, listen up here. Now, you're saying that how do you suffer loss or opportunity loss? You're saying that opportunity loss is benefit foregone for not making a given decision. This is what I mean. For example, if the outcome was good, the demand was good. Here you had 3 products. Which one could have given you the maximum profit? If you had the information, this is what it means. If you had the information and these are the profit you expected, which one could you have chosen? Gross. Which one will give you a profit of 120? What if you decided to select silk? Silk will give you a profit of how much? 70. But in case you had the information, you could have taken 120. So that means for not taking this 120, you will suffer a loss of how much? 50. If you had the information, when the demand was good, you could have taken gross, you get 120. But if you decide to take mark, it will give you 100. Now the question is, if you take 100 and you have to take 120, that means you lose how much? 20. If you had the information you could have taken gross, you get a profit of 120. If you take that gross, how much will you lose? You lose 0. So now give me EOL, that's the average. Now this is how you get EOL. For example, for silk, you can suffer a loss of 50,000 with a probability of 0.75, or you suffer a loss of 0 with probability of 0.15, or you suffer a loss of 4 with probability of 0.1. So, get what 1,500? You get what 1,500? 41,500. This is 15. How much is this? You get 16? $17 to 50. 17 to 50. That's 0. That is 750. That's 4. You get, is it 4150? 4150. Now, remember these are losses. Which one will you select based on the losses? You will take? Cross. You take the one with the minimum loss. That's cross. A minute. So we are required number 2, compute the expected opportunity loss for each decision. So you already have for each decision. And then which decision would you recommend based on your EOL? So you should go with gross because at least these are losses. So you take the one with the minimum loss. Number 3, compute the expected value of perfect information. So how do we get the value of information? Now, the value of information, I give you formulas. You take number 1 is the row of EOL. That means the value of information should be 4150. You already have EOL. So the row of EOL was 4150. That's how you get your 5 marks, 4 marks. Or alternatively, to get the value of information, you take EMV with information minus EMV without information. And EMV without information is also what we call the selected EMV. Yeah, the one we selected here, EMV, the selected one was 93,500. Now, how do we get EMV with information? Now, first of all, let me define what we mean by value of information. See that value of information is the maximum price paid to acquire information, or maximum profit obtained for acquiring information, or maximum loss suffered for not acquiring information. Now, if you have the information, so how much could be the expected monetary value? Now, you take, you look at the outcome. If the demand was good and you had the information, which one could you have selected? 120, the one with the highest profit. So it's 120. And the probability that the demand will be good was 0.75. Plus, if the demand was moderate and you had the information, which one could you have selected? You could have selected the highest, which is 55. So you take 55. And the probability that the demand will be moderate is 0.15. Or if the demand was poor and you had the information, which one could you have selected? Negative 6,000. And the probability that demand will be poor, it's 0.1. Now that's what we call EMV with information. Then you raise EMV without information, which is the selected EMV. Now here we had computed EMV. So the one you selected was 93,500. So what do you get? Sorry? 4150. Which is the same as that. Good. Can copy? We try another illustration. May 2017, question 2C. ABC Limited has recently developed a new product named X. The demand for X is expected to be low, medium, or high. Now, those are the outcomes with probability of 0.25, 0.45, and 0.3 respectively. The product is to be manufactured at small or large. So small or large. So those are the options, either small or large. Production with the following annual profit estimate. You're also given the payoffs. So you have the small scale production, large scale production. So let me just summarize for you the payoff table. We say that payoff means the profit. So here we have the option, here we have the outcomes. So option, it's either you produce on a small scale or large scale production. Then here you have the probability of the outcome. Then the outcomes is based on the demand, of which demand can either be low, can be medium, or can be high. Even here you can compute the E and B. So you have the probability. The probability that the demand will be low is 0.25. That will be medium is 0.45. There is 0.3. And then we have the profit. Now let's start with the small scale. Now small scale, you have the profit. For low demand, the profit will be 40. Medium, 140. High, 180. The probability is the same. And then for the large scale, profit can be 5. When medium, 90. The year we have is 280. Required. Advise ABC Limited on the best course of action based on the following approaches. Number one is the expected profit. Now, expected profit is the same as EMV, of which you take the summation of the profit times the probability of occurrence. Now, this is what I mean for small, for large. Now, small, it's 40 million with probability of 0.25, 140 with probability of 0.45, or can be 180 with probability of 0.3. For large, it's 5, probability of 0.25, can be 90, probability of 0.45, or 280 with probability of 0.3. So what do you get? $120? $127? $125.75. Now, based on the EMV, you take the one with the highest profit. So the highest profit is 127, and therefore they should produce in small scale production. Number 2 of the question, minimizing risk. So they want the objective to minimize on risk. So under decision making, we see that there are two methods which can be used to evaluate the risk of a project. One was the standard deviation. Number two was the coefficient of variation. So in this case, we can use either the standard deviation or CV. That's the method of measuring the risk. Now let's start with standard deviation, or let's evaluate using the standard deviation. And standard deviation, this is an absolute measure of risk. And how do we get the standard deviation? Standard deviation will take returns minus expected return, square, probability, summation, then you get the square root, which is equivalent to, now return is the same as profit. Now expected return is EMV. Now, in case you're evaluating the number of units to produce, in case it's unit, you could have taken X minus X bar, which is the average, square, probability, summation, then you get the square root. So we get standard deviation for the small scale production. This will get the standard deviation for the large scale production. So we'll take returns of the profit for the small scale. These were the profit, 40, 140, or 180. You compare against the expected returns for small, and this expected profit. The expected was 127, 127, 127. Then you square times probability. Probability of generating 40 was 0.25. Generating 140 was 0.45. And this one was 0.3. Do the same for the large scale. You take returns of the large scale. We had 590 to 80. Then you minus expected return. For large scale, the expected return was 125.75. Then you square times probability. So probability was 0.25, 0.45, and 0.3. So now give me that. Sorry? 1892.25. $76.05. Sorry? 0.7. Now let's add the total. Right? 2811. Then you get the square root of the answer. Now let's do the same here. First one. So, point. 71 point. That's 7 point. Sorry? So now let's add the total. 0.19. Then you get the square root of the answer. Now, standard deviation, you see that this is the absolute measure of risk. And then for standard deviation, since the measure of risk, the higher the value, the higher the risk. Now, comparing between the two, which one has the highest risk? Let's do it CV. So how do we get CV? Now, CV, the coefficient of variation, this is the relative measure of risk. Let's take the standard deviation of my expected turn, you multiply by 100. So, but by the virtue of that, you can be able to make your decision. Also, now let's make a decision based on the CV. So we have the small scale production, and then we have large scale production. So here you take the standard deviation. This is 53.02. Here you have it 106.57. And then you divide by EMV. Now for small scale, the expected monetary value is 127. Then you multiply by 100. And this was 125.75. That's 100. Sorry? 0.75%. 41. 84.75. But the two are mutually exclusive. You choose one. So you comment. So you write your own comment. I think I've explained when I was explaining this. If you didn't listen, you make a wrong comment. So you can copy. So and that marks the end of that session. So now we have done calculus and decision making.